The plasma tornado is a beautiful display of plasma from a simple glass jar. The plasma can take different forms according to the input voltage and frequency, and also depending on the pressure inside the glass vessel. This device also projects a radiant energy field, which will light up other gas-filled vessels at a distance without wires. The plasma vessel here just contains normal air at a low pressure. A power supply is needed to create the plasma. This is a high voltage, high frequency power supply, but no exotic gases are required like neon or argon. This is just normal air at low pressure. Now you can get this jar from us with or without a vacuum applied to it, but if you get it without a vacuum, you'll need to have a vacuum pump on hand or access to a vacuum pump because lower pressure air is required to get a full plasma to form. Also, having a vacuum pump will let you adjust the pressure in the jar, and you'll find there are different visual effects at different pressures. You might also find that the strength of the radiant energy field could change according to the pressure, the gas pressure in the vessel. This kind of data could be part of a good research paper or thesis, or you could just do it for fun and see what happens at different pressures. Now, as mentioned, a power supply is required to create the plasma. We have two power supplies that will work for this. One is our TCL50, which is also a small Tesla coil that does some other things like make a Jacob's ladder. It's a pretty cool item on its own. The other power supply is our PVM12. This doesn't have any additional functions like the TCL50. It's just a dedicated power supply for neon and plasma devices. On the back of the PVM12 is the high voltage output wire. Just attach this wire to the copper tube. I'm using a wire with a couple alligator clips to make an easier connection, but you could use a paper clip here if you wanted, as long as the high voltage output wire connects the copper tube. We sell the PVM12 with this stripped lead because a lot of people will solder this to the load they're driving for a more permanent connection, but you could just put an alligator clip on here if you wanted. If you're just going to connect it and disconnect it to this copper tube, an alligator clip would make that nice and easy. In this case, I've just got this wire with two alligator clips on it. Make a quick connection like that. Now keep this wire in the air if possible. If it touches anything grounded, or if it's even close to anything grounded, it can lose voltage. That's called a parasitic voltage loss, where basically the high voltage will get through the insulation to the ground and you'll have a lower output voltage at the end of your wire, which will reduce the effect. So just keep this wire suspended in the air if possible. This is a short wire, so it's easy to do. And the same with the jar. It works better when it's away from anything that might be grounded. For example, this is just a plastic coffee jar lid, but it gives a little distance from the table, and it's plastic so it insulates. The table is wood, so it isn't a conductive ground like metal, but it has some grounding potential. So this plastic lid makes a good insulator. The PVM12 runs on 12 volts DC input, which goes in here. A 12 volt wall adapter is included. First plug it into any standard wall outlet and you've got 12 volts DC to run your power supply. This can also run on a 12 volt battery. Some batteries have a jack that will plug directly into this, or we also include this wire. So if your battery has a couple of terminals, like with a car battery, just attach these wires to the terminals, plug in this jack, and your power supply can run from the battery. But we'll just use the wall adapter here. For the other wires on this power supply, this in the back is the high voltage return wire. For this plasma tornado, you don't need to attach this to anything. With the plasma tornado, the high voltage return is into the atmosphere. That's what the radiant energy field is. You also don't need to attach this dedicated ground wire in the front. Just leave these two wires unconnected, and with this setup, you just turn on the power supply and adjust for resonance. When you turn this frequency dial and get the greatest plasma output, you've found the optimal frequency for this resonant system. I'll turn off the lights so you can see the plasma a little better. The plasma output is really quite beautiful when you look closely. And the video, it really doesn't do it justice. It looks much better in person. I've noticed this as I'm shooting and editing this video. Sometimes I need to go back for a little more footage and every time I am amazed by how much better the plasma looks in person. I mean, it looks good in the video, but so much better in person. The other power supply is the TCL50, which can also make a Jacob's ladder, but that's a separate video. The high voltage output is here, and to get the plasma going, just attach a wire between this output and the plasma jar. I'll again use a wire with a couple of alligator clips. We include this little light bulb socket with the TCL50. You can get something called a decor bulb from just about any hardware store, and it makes a neat little plasma display with the TCL50. But that's also a separate video. Here we're just going to connect a wire to one of the blades. Then plug this in a little bit, and now you've got your high voltage output through the wire. And now you're ready to go. Same thing as the PVM12. This runs on 12 volts, comes with a wall adapter, and also runs on a battery if you want. And you don't need to attach the high voltage return wire or the ground wire. Just turn it on and adjust for resonance. Again, I'll turn the light off so you can see. As the frequency dial is turned, you'll notice the plasma output changes its intensity and behavior and seems to fill out the glass vessel in different areas. Also, if you can see it in the video, you'll notice how the plasma appears to swirl around quickly, and that's why we call it the plasma tornado. You might also notice that what appear to be little discs can form in the plasma just off the end of the copper tube, a couple inches down maybe. Those could be high and low pressure areas, or they could be something else entirely. What do you think they are? Why might the plasma behave in this way? There are a whole bunch of things going on here that could be good research topics, and you might notice some other phenomena occurring that I don't see here. Maybe at different frequencies, different pressures, or other changes to the setup that you can think of. You can also see how a radiant energy field works. Here I'm holding a compact fluorescent light. If you hold the metal end, you get a much greater output. There's another good question. Why do you think that would be? Why is it behaving that way? And this is a standard fluorescent light tube. Hold it from one end at the metal and it lights up pretty nicely along the length, fading a little towards the far end. If you hold it at both ends, it's brighter where you hold it, but there's a dead spot at the middle, even though the middle is closer to the radiant energy source. So there's a lot of good stuff going on here to think about and discuss what's happening. And here's some neon in the radiant energy field. Not everyone has access to neon. It's not as popular as it used to be, but it has such a lovely warmth to it compared to the crisp brightness of LEDs, which are also nice, just different. This radiant energy field will also light up spectrum tubes, as long as the spectrum is a wavelength you can see, of course. This is water vapor. I don't know if you can see that. It's a very faint white line. Nitrogen gas. Carbon dioxide. Helium. Krypton. Mercury vapor. Neon. Iodine vapor. The plasma also responds to touch, although there's a little bit of plasma created between your finger and the glass. I don't know if you can see that. The plasma isn't getting through the glass, but rather the high voltage emanates from the glass, and when you get close enough, it goes to your finger. So there's a little bit of plasma created between the outside of the glass and your finger. It doesn't hurt at all, but it very slightly will start to etch your skin if you leave it there too long. Again, it's not dangerous, just something to be aware of what's going on. Now, if you have a vacuum pump, you can pump down the jar to different pressures and see how that affects the plasma behavior. These are a few examples, and I'm not going to say what the pressure is because that's a big part of the fun and reward of doing the experiment yourself. It's just much more engaging when you discover things. And who knows, you could find a very specific pressure that gives a unique pattern nobody has seen before. So that's our plasma tornado. It makes a neat display and a great learning tool, either for yourself, in a classroom setting, or as a museum demonstration. So enjoy it and let us know if you have any questions. Thanks, guys.